Hi, welcome back. Lath. Lath provided a means of holding the plaster in place. Wood lath was nailed at right angles, directly to the structural members of the buildings, the joints and studs, whether it be timber frame buildings or balloon construction of today, or it was fastened to non-structural space strips known as furring strips. Three types of lath can be found on historic buildings from 1710 through the early 20th century. Wood lath is actually made up of a narrow, thin strips of wood spaced in between. In England, it was primarily of oak. Here in the colonies, it was some type of fir. Is applied in light pressure to push the wet plaster through the spaces between the lath. The plaster slumps down the inside of the wall, forming plaster keys. So you have to have adequate push through the spaces. The keys hold the plaster in place. Metal lath. This was patented in England around 1797, hard to believe, but it began to be used in parts of the United States toward the end of the 19th century. The steel making up the metal lath contains many more spaces than the wood lath it contains, so hence a lot more intense keying, less cracking as a house settled. These spaces increased the number of keys. The metal lath was better able to hold the plaster than wood lath had been since the beginning of the process occurred. Rock lath, a third lath system commonly used and is also called plasterboard or gypsum lath in use early in the 1900s. Rock lath was made up of compressed gypsum covered with a paper facing. Some rock lath was textured or perforated to provide a key for wet plaster. A special paper with gypsum crystals in it provides the key for rock lath used today. When wet plaster is applied to the surface, a crystalline bond is achieved. Rock lath was the most economical of the three lathing systems. Lathers or carpenters could prepare a room more quickly. By the late 1930s, rock lath was almost used exclusively in residential plastering. Common plastering problems. This is where the conservator kicks in and really supersedes architects. Architects are really not keyed in for this type of detective work. When plaster dries, it is a relatively rigid material, which should almost last indefinitely, absolutely, if not exposed to water. However, there are conditions that cause plaster to crack, efference, separate, or become detached from its lathwork framework. These include structural problems of the dwelling, poor workmanship, improper curing or mixing, and moisture. Structural problems. When overloading stresses within a wall occur or acting on a house as a whole can create stress cracks. And inletting or infilling of bricks into timber frame construction after 200 to 300 years causes this to happen. Appearing as diagonal lines on a wall, stress cracks usually start at a door or window frame, but they can appear anywhere in the wall with seemingly random starting points. Builders of non-historical houses had no codes to help them size the structural members of buildings. The weight of the roof, the second or third stories, the furniture, and the occupants could impose a heavy burden on beams, joints, and studs. Even when houses were built properly, later remodeling efforts may have cut in a doorway or window without adding a structural beam or header across the top of the opening. And in a dwelling I'm looking at right now, they pulled the diagonals out of each corner by adding doorways, and they severely weakened the overall structure from racking. Occasionally, load-bearing members were simply too small to carry the loads above them. Deflection or wood creep, deflection that occurs over time, can create cracks in plaster. Overloading and structural movement, especially when combined with rotting lath, rusted nails, or poor quality plaster, can cause plaster to detach from the lath. The plaster loses its keys. When the mechanical bond of the keys with the lath is broken, plaster becomes loose or bowed. If repairs are not made quite expeditiously, especially to ceilings, gravity will simply cause chunks of plaster to fall to the floor. Settlement and vibration. Cracks in walls can also result when houses settle. Houses built on clay soils are especially vulnerable. Many types of clay are highly expensive. And also, don't forget the resulting of wood fibers eventually drying out over 2 to 300 years. In the dry season, water evaporates from the clay particles, causing them to contract. During the rainy season, the clay swells. Thus, a building can be riding on a very, very unstable footing. Diagonal cracks running in opposite directions suggest that house settling and soil conditions may be at fault. Similar symptoms occur when there is a nearby source of vibration, such as heavily transported roadways or railroads. Blasting is another possibility, or as we said, train lines. Lath movement. Remember that lath is wood. Wood moves between season to season, heating to season to cooling season. Horizontal cracks are often caused by this kind of lath movement. It absorbs moisture from the air. Wood lath expands and contracts as humidity rises and falls. This can cause cracks to appear year after year. Cracks can also appear between rock lath panels. A nail holding the edge of a piece of lath may rust or loosen, or structural movement in the wood framing behind the lath may cause the seam to open. Heavy loads in a storage area above rock lath ceiling can also cause ceiling cracks. Errors in initial building construction, such as improper bracing, proper corner construction, faulty framing of doors and windows, and undersized beams and support systems and floor joists eventually telegraph through the plaster. Poor workmanship. This is very common, particularly in this area in South Jersey, where you have virtually no trained carpenters in this tri-county area. In addition to problems caused by movement or weakness in the structural framework, plaster durability can be affected by poor materials and workmanship. The first is a poorly proportioned mix of the plaster compound. The proper proportioning and mixing of materials are vital to the quality of the plaster finish or job. A bad mix can cause problems that appear years later in a plaster wall. Until recently, proportions of aggregate and lime were mixed on the job. A plaster may have skimped the amount of cementing material, which is the lime, and gypsum because it was cheaper. Over-sanding can cause the plaster to weaken or crumble. Plaster made of a poorly made proportion mix may be very difficult to repair and do any restoration work on. Incompatible base coats and finish coats. The use of perlite as an aggregate as opposed to sand also presented many problems. Perlite is a lightweight aggregate used in the base coat instead of sand. It performed well in cold weather, but has a slightly better insulating value. But if a smooth lime finish was applied over the perlite base coats or wood on rock lath, cracks would appear in the finished coat, and the entire job would have to be redone. To prevent this, the plaster had to use fine silica sand or finely crushed perlite to the finish to compensate for the dramatically different shrinkage rates between the base coat and the finish coat. So whenever you have this issue, try to use a base coat of sand through the 3 coats or perlite.